Yes, Joe, I'm okay.
All right. So that's going. So thank you again. We are gonna have today Winfrida presenting us on her part of her work on her PhD thesis. Without further ado, Winnie, please take it away.
Okay, greetings everyone. Good morning, good afternoon. As introduced, I am Winfrida Moita, and I am a PhD fellow under the D43 track program based at KSMC University. And what I'm presenting today is one of the papers among my 3 PhD series paper. And today I'll be sharing findings from the second paper, which looks at whether age moderates the effectiveness of a brief intervention called PPKY. So in reducing alcohol use among injury patients, alcohol use and alcohol-related consequences among injury patients. So I believe for those who have been for a while in these calls are aware of PPKY. So for this paper, I'm just looking at age differences in the response to a brief intervention, PPKY. And PPKY, it's an acronym for a Swahili word called Punguza Pombe kwa Afya Yako, which translates to reduce alcohol for your health. And this work is, in terms of analysis, it's a moderation analysis. So brief intervention, what we mean by brief intervention, simply these are those practices that aim to identify a real or potential alcohol problem and motivate an individual to do something about it. And in northern Tanzania, a brief intervention has been culturally adapted. So it's a brief negotiation intervention has been culturally adapted for injury patient presenting to emergency department in a tertiary hospital in northern Tanzania called KSMC. And this brief intervention is called PPKY. And in our study, we have an operational definition for two main groups of people, two main age groups. So we have young people and we have adults. So when I say young people, I refer to individuals in the age of 18 to 24 years age group, even though WHO refers to young people from 10 to 24 years age group. But why 18 to 24 years age group? Because these are the people who were given this intervention. Like the intervention was given to people aged 18 years and above, but also it's the legal drinking age in Tanzania. And adults refers to individual aged 25 years and above. And these groups have other behavioral and neurobiological differences. Studies and also our first paper have shown that young people are more likely to engage in heavy episodic drinking, while adults may have more habitual drinking patterns compared to young people. But also in terms of neurobiological differences, we know that up to the age of 24 years, it's still a period of ongoing brain development, and exposure to alcohol to this age group can alter neural pathways related to impulse control and reward processing. So these young people are more likely to have, they are vulnerable to hazardous drinking pattern, and they are more likely to develop alcohol use disorder in the long run compared to adults. So this age group differences has a very distinct behavioral and neurobiological differences in terms of alcohol use and consequences, and also in terms of intervention responses. So Tanzania has a very high alcohol consumption rate. Currently, it's the third in Africa, and the consumption is 9.4 liters per capita compared to the regional average of 6.4 liters. And KSMC, which is located in Kilimanjaro, so Kilimanjaro has the highest drinking rates in Tanzania, and at KSMC, a tertiary hospital in the northern part of Tanzania, up to 30% of injury patients have been shown to test positive for alcohol use, and this is by breathalyzer test. So prior work have been done to try to adapt an intervention for injury patients who have harmful drinking patterns. So we have PPKY, as I introduced it earlier. There's a lot of work which has been done, and it has been shown to be feasible, acceptable, and it has been culturally adapted for Tanzanian emergency department settings. So prior work has also used a pragmatic, randomized, adaptive control trial design to look at the effectiveness of this brief negotiational intervention called Punguza Pombe kwa Afya Yako. And it has shown to reduce binge drinking days. It has been shown to be effective to reduce binge drinking days, frequency of drinking, and total alcohol consumption. And this was assessed at 3 months of follow-up. So, despite that, different studies have tried to show mixed evidence on the effectiveness of brief intervention. So why age matters? So other brief intervention have showed mixed evidence. Some show stronger effect in young people compared to older groups. And meta-analysis, sorry, I forgot to cite, meta-analysis by Elzorabi in high-income countries have shown that brief intervention, they seem to be less effective in injured patients, but they said it was mainly explained by age differences between the group. But also we know that age has a very big effect in motivation and behavior change, which the brief negotiational intervention try to motivate you to change your behavior. And this can be explained by the trans-theoretical model. And we know that young people have different drinking patterns. They are more likely to have more binge drinking and impulsive drinking. So they might respond different and might need tailored intervention compared to adults who have more entrenched drink pattern, and they might also respond differently to brief intervention. So building to this, we thought there is a gap. We needed to see if age moderates the effectiveness of the brief intervention, PPKY, in Tanzania Emergency Department. And this is also very important considering that alcohol is the main contributor to injuries, and injuries currently are the leading cause of death among young people in sub-Saharan Africa. So to answer this, we thought of doing moderation analysis. So with moderation analysis, you're trying to see to whom or under what condition does your intervention work best. So in moderation, you are trying to test if there is an influence of a third variable on your exposure to our outcome. And in this study, our main exposure was PPKY, which is a brief intervention, as I said, and our outcome are alcohol use and other alcohol-related outcomes. So our third variable, Z, as I'm trying to show this relationship, Z is the age. So we want to see under what condition does the intervention work, or to who is benefiting more to this intervention. So this is what we wanted to see in this study. And the main aim of this study is to determine whether age moderates the effectiveness of the PPKY brief intervention in reducing alcohol use and related outcomes among injured patients in northern Tanzania. So we did a secondary analysis of the PRACT data, PRACT trial, and we used data from October 2020 to March 2025. And this study was conducted at KCMC Emergency Department in northern Tanzania. So participants in the trial are acutely injured patients, so less than 24 hours, and patient has to be 18 years and above. And the patient has either to meet one of these three conditions, either have an audit score of greater or equal to 8. Audit is a screening tool for alcohol use disorder. The patient or has to admit pre-injury alcohol use or has to test positive on breathalyzer. So and or any of the three conditions. And participants are either given usual care or they can be randomized into the intervention arm, whether PPKY intervention or with SMS boosters, which are sent weekly, or personalized SMS boosters to change behavior. So these arms, intervention arms in this study, were all pooled and compared to usual care. And for the primary outcome for this study was binge drinking days. And I'll show the definition of the outcome variables. And we had secondary outcomes for drinking days, drinking amount, audit, which is for alcohol use disorder, drink, which looks at alcohol-related consequences, and PHQ-9, which assesses the depression. So the primary outcome, binge drinking days, was defined as number of days in the past 28 days where a person had a binge event. And these binge events, for men, it's more than 5 standard drinks per sitting or per occasion. And for a woman, it's more than or equal to 4 standard drinks per occasion. So participants were asked in the past 28 days, how many times did they have those binge drinking days? The secondary outcomes were drinking days. So this was looked at in the past month or 28 days, the number of days that a person had drinking days, drinking amount, which was a total of standard drinks in the past 28 days. We also had a secondary outcome of audit score and drink score. As I said, drink is for drink-related consequences, and it's a 50-item scale. And PHQ-9 score, which looks at depressive symptoms. And our moderator variable was age, which was intentionally categorized into 2 age groups, 18 to 24 as young people, and greater or equal to 25 years as adults. So we did our analysis using Stata version 17, and we did complete case analysis. We fixed models depending on the outcomes. So we had outcomes which were counts. These were binge days, drinking days, and drinking amount. And for these outcome, we used mixed effect negative binomial regression model, because we didn't go for Poisson here. We went for negative binomial regression model because of how this outcome is in our data set. So some participants had a lot of 0 binge days, while others were reporting high binge days or drinking days and drinking amount. So there was a very big over dispersion. And we tried Poisson and negative binomial regression. A negative binomial regression model was fitted better our data set, because it would take into account, it would handle well the over dispersion in the count outcomes. And for continuous outcome, which were audit, drink score, and PHQ-9, we did mixed effect linear regression. So these outcomes also were not normally distributed. So we did log transformation, but also there were a lot of, there were some zeros, especially at 3-month follow-up. So we were adding 1 to the score. So a score and then +1 and then log transform. So I'll show our findings as beta coefficient, but they were log transformed. And we fixed the random intercept for participant, because we had 2 time points. And our main interaction, was tested at 3. We did 3 interaction, main one, but we also tried other interactions. So we had time, intervention, and age. And we did this because we wanted to test whether the change over time in the there was a change over time in the intervention effectiveness. Did it differ by age? And we adjusted for priori confounders. So we adjusted for sex. We thought sex would have a confounding effect, baseline audit score, and baseline PHQ-9. So depending with the model, we would adjust for the specific confounder. So like when audit was our outcome, we didn't adjust for audit, baseline audit. So we also did some sensitivity analysis to see how the robustness of our findings. So we did also multiple imputation, and we also tried to model age as a continuous moderator to see how to see the effectiveness of the intervention, or how it would work if we did that. So these are findings, and at baseline, so these are baseline group comparison by age, and we had a total of 530 participants. We see majority were adults, so 84% were adults, and only 16% were, around 16% were young people. And in terms of sex, groups were quite balanced by sex. There was no any statistical significant difference. And we can see that adults were more educated. Most of them were in professional skilled employment, or skilled employment compared to young people. And they had high monthly personal income. So they were more socioeconomic, young ones are more socioeconomically vulnerable compared to young people. That was not surprising. And looking at the baseline alcohol-related variables by age group, we found, we observed at baseline, like adults reported significantly more drinking days compared to young people, and this was the median number of drinking days. So adults had 6, while young people had 2. And while in the contrary, young people had higher score in depressive symptoms compared to adults. But there was no, other alcohol-related measures were not statistically significant. So we looked at the effect of PPKY on at 3 months. And as I said, adjusting for sex, baseline audit, baseline PHQ-9, and what we see here is the incidence rate ratio for mixed effect negative binomial model. So we observed a significant reduction in binge drinking days over time. So the first thing that we're seeing is if we look at 3 months compared to baseline, we see a 73% reduction, 77% reduction in binge drinking days over time. However, there was no statistical significant difference between the intervention and usual care arm. And our moderation, if we look at time and intervention, or time intervention and age, the moderation was not, there was no evidence of moderation. As we can see, the p-value was 0.741. So looking at the secondary outcomes at 3 months, we see that at 3 months, across all outcomes, like if we look at the effect of time, we saw a significant reduction. Like if we look at drinking days, there was 70% reduction in drinking days. Here we see a 76% reduction in drinking amount. Also, the audit score significantly reduced, and the drink score also significantly declined over time. But if we look at the intervention, there was no any evidence of statistical, the reduction was not statistically significant if you compare the intervention to the usual care. Also, the interaction was not statistically significant. But also we noticed a modest increase in depressive, in PHQ-9 score over time. And this was statistically significant. So for the other sensitivity analysis, so we did multiple imputation, and here we assumed missingness by random, and results were consistent with the complete case analysis, so there was no change in the conclusion. We also tried to to model age as a continuous variable instead of binary. And also there was still no evidence of moderation by age group. The p-value for the interaction was still greater than 0.05 across outcomes. So the stratified analysis, we despite the interaction being not significant, we also tried to explore stratified analysis, tried to see how this intervention was working for young people compared to adults, to see if there was any pattern that we could pick. So here, what we can see, the blue is the young people and the green line is the adults. So these explanatory findings, what we can see, we see among young people, so the blue one, among young people, there was a reduction. Sorry, I should have shown the table because it had better value. So among the young people, there was a reduction in binge drinking days and amount. So for young people, this is what we could see, like reduction in drinking days and drinking amount. But for the adults, there was broader reduction in outcomes, but this was, the effect was due to time rather than the intervention. And while for the young ones, it was due to the intervention. So we thought these differences. So what we are thinking after this is there was an effect of time. For the young people, we saw mainly the effect of time, like the intervention did not do much, but they reduced their alcohol-related outcomes naturally over time. So for what I'm trying to say is like the adult ones, there is a natural reduction in alcohol-related problems, depressive symptoms, and alcohol use over time, regardless of the intervention. But for the young ones, time didn't seem to reduce anything, but the intervention was effective in reducing binge drinking days and frequency. So we thought due to that, the young people, them just having an injury or that contact to the hospital is a teachable moment to them. While for the young people, improvement was seen after them being given intervention. So the implication would be the young ones could be the ones who are benefiting somehow to the intervention compared to the older ones. But we would need to now to work it better for them so that it can reduce other alcohol-related outcomes, such as to reduce drinking frequency and drinking amount. So, and that is, the next step would be to use that information to co-design the PPKY with young people so that it can try to ask them and try to ask people who are involved, people who are delivering the intervention, involve young people who have had who are given the intervention, and also young people, other young people who haven't been beneficiaries of the intervention, try to have participatory approach, participatory workshop with them to co-design an age-appropriate brief intervention for them based on what we have found from this study. Thank you.
Thank you, Winfrieda, for presenting. I have several questions. I'm going to start going through and then have folks.
My screen? Can you see my screen?
No, I think you stopped sharing. Can you pull it back up, please?
Yeah.
Okay. Can you go all the way back to the methods? Yeah. Okay. So All right, go to the next one. Okay, so here the first question, and I think Ashley was chatting with me about this, is this breakdown of age between 18 to 24 and above 25. What is the rationale for that?
Okay. So the rationale was WHO defines young people as people aged 10 to 24 years. So they are well known as this group to be called young people. And other studies have tried to explore the drinking patterns among young people. And also we have even a WHO guideline talking about drinking pattern in young people, which is different from adults. And also they have different, like it's still a stage, studies have said it's still a stage of brain development. So yeah,
Okay.
in terms of drinking behavior, they might be different from adults, but also in terms of neurobiological differences. So like still there is, if you drink at this age, they have evidence has tried to say like there's neuro pathways related to impulse control and reward processing are still developing, and exposure to alcohol at this age group, like below 24 years, can have higher alcohol-related consequences compared to adults. So even other studies have been trying to say like we should raise the drinking age.
Mm-hmm.
Yeah, so that was the logic behind this.
Okay. Yeah, I'm just thinking that it's every time you choose a arbitrary marker, it every time you dichotomize data, you're making several assumptions in there. And I agree, even though WHO says that this is young adults, what is the real difference of a 24 to a 27 on drinking pattern or biology for that sense? But then you assume a lot of things in your decision there. So I'll be careful of using this dichotomy as a set in stone thing, because maybe you will end up finding no results, and it doesn't mean that age doesn't impact. It just means that this breakdown of age you've created doesn't seem to have an association with the effectiveness. Associated with that, what is the proportion breakdown of this? I don't recall if I saw it on the table. How many people are within each group?
15% were young people.
Yeah, and then there
10%,
alone also
84 were adults.
you also have a big problem with your balancing the classes there. Like 15% is not a lot compared to the other 75, 85. So just to think about that, maybe there's another way to look at this that's not necessarily just this breakdown. That I think you end up making several very strong claims in the end that might be much more due to some noise in the analysis than necessarily what the actual data is showing. I want to, Ashley has a hand up, so I want to.
Yeah, I just wanted to say before we move from the topic of the age dichotomy, I heard your rationale that you answered, Joao, which can explain, why we might have some differences in these two groups. But what I didn't exactly hear, which would be the most relevant to your particular study, is why you think that the intervention may behave differently for these groups. So you can make some assumptions based on your response, but I didn't exactly get, yes, they may be at higher risk or have certain other predispositions, but why do we believe the intervention should work differently for one of the groups versus the other groups? I think if you're going to stick with a dichotomy of any kind, I think we need to, well, actually, just looking at age as a moderator, we need to understand why you think it may have a different effect on those different populations?
Also, I tried to look at the drinking pattern. Like the first paper was to compare the drinking pattern between this age group, but I understand actually that might not answer it, because again, that kite point was still the same reason. So I'll work more on that to have a
Well, I think in your introduction, you talk a little bit about the prior data showing that young people have a better outcome from BI than other people in some literature. So I think
So I probably missed it then.
there
Sorry.
is, yeah, there was a little rationale there. I'm just
Yes, other studies also on BI have tried to look. They have tried to explain age, but of course they didn't use my cutoff points, the same cutoff points.
right, which is fine. Okay, let's move further along.
Yeah, you also make an argument that those who are younger drink less. So then naturally an intervention is going to work differently when you have lower numbers to drink, right? You have a different amount to reduce. And so even within the data, if your groups are looking different at a younger age, then it's going to have a different effect after the intervention, just because the numbers are starting from a different baseline.
Yes. Sorry, Catherine. Sorry, I think I didn't get you well.
Well, we're talking about young people and how much the intervention might be or might not be working for them. There's literature that suggests that part of the reason it might not be working for them is they have different preliminary baseline amounts of alcohol use, right? They don't drink as many days, and they might not drink as much because they're younger and earlier in their drinking continuum. And so you're going to see different effects just statistically because you're dealing with lower numbers for this age group. And it doesn't mean it doesn't have an impact for that age group. It just means you're going to see different effect sizes because it's easier to make a big change when you start out with 50 drinks than if you start out with 20 drinks per month.
Okay, so go to the slide 13. Okay, so this slide, you're breaking them down by groups. In the 3-month efficacy paper, we organized these classifications a bit more, just because the comparisons here are harder to read when you have so many categories that means same things. So I would just think about the employment categories there. And then the differences in education, that makes a lot of sense, but it's something we might need to consider adjusting for when you're analyzing this data, because now you're looking at groups that have biases between them. Okay. So here you see that it's clear that there's some differences here. You would expect young people to have less education and probably have less or more unstable jobs. So we might need to adjust for that when you're analyzing the data, which maybe you can just adjust for that in the income. But okay, go for it.
I can adjust for income and education, right?
Sorry, Winnie, say it again.
You said I can also adjust for education and income.
I would think so, yes. In your model. Go further down. Okay, on 14. Also, I don't recall in the methods if you said what kind of method are you using to compare the outcomes on slide 14?
What kind of method here? Sorry.
Yeah, what is the p-value about?
Oh, so the p-value was for the median.
Right, but you estimated at how?
I used, it was not normally distributed. I used the Will Coxon ransom?
Okay. All right. So
Looking at the distribution of they were all not normally distributed.
yeah,
So
no,
I went.
that's fine. Yeah, but the problem with this comparison here is that you're gonna be obviously unpowered for, and the p-value is just a marker of significance, but I'm not sure how relevant this is on the comparison itself. So I wouldn't be too hung up on what these results mean.
Sorry, Joe, if it's not if if that's the problem, that so it also means it's also the problem in the regression model.
Yes,
Comparison.
that is correct. That's why you focus much more on the magnitude of the effect and the confidence interval. Then you focus on the p-value as a binary marker of significance or not. Okay. All right. Okay, so then this model I'm having trouble with. So how did you fit this model? Did you have the 3-month outcome as the 3-month version as the outcome, and then you had baseline as a confounder? You calculated the differences between the two and then have the time. How did you fit the model here?
So I was modeling I changed my data to, because it had a lot, like I was looking at 2 time points, I kept it in long format.
Okay.
And I ran one model. In that model, I had already created variables for like it would compare baseline and, 3-month and baseline. So, and I was adjusting, like here, the outcome was binge drinking days. I was adjusting for baseline audit and PHQ-9 and sex. But
Okay.
it's one model, and it also had the interaction term. So it gave me the output, the full output.
So you had the long version with 3 months and baseline as one additional key variable, and then intervention on intervention.
Yes.
And then you had age groups.
Yes.
Okay. And then I think next time when we talk about this, it might be good if you could push the codes here so we could see how you fit the actual model. That might be helpful for us to see. And so I'm assuming here, this is a complete case analysis. You dropped every meeting. Are you working from the clean database that we have developed on the primary analysis, or did you clean it yourself?
So I had talked to Timothy had cleaned the data and he had 540 people. I did my own cleaning. I had 530 people.
Right. And so I think we need to, the first thing here, Winnie, and we're not going to go through this here, but you need to engage with Linda and João Victor and make sure you're using the cleaned data. Because if we're all going to get the raw data and clean, then all the work we've done on pushing this data to be standardized on how it's to be used, then we can't really be sure how you clean this data and made the same assumptions. Okay.
Okay. I talked to Linda at that time. She was pleased.
Then the other question that I had here is, you're adjusting for sex, baseline audit, and baseline PHQ-9. Why did you do that?
So I had planned to adjust for them from the beginning before even the analysis, because I was thinking of them to be prior confounders. So let's say on binge drinking days, despite the baseline differences, I thought they would still be strong confounders for my outcome. So I was going with the more of epidemiological reasoning rather than the baseline differences.
Yeah, I think there's a big. Do you think the audit score is a confounder of binge drinking, or are they two collinear?
They're collinear, actually.
Yeah. Do you see the issue there? Which is fine. You're trying to adjust for their baseline drinking, but you have that somehow in your model when you're looking at the variation over time. So I think you're confounding yourself. I don't think that will change the analysis, but I just think that as a concept to fit the model, that's probably not the best idea. And then when you bring the PHQ-9, we're not 100% sure the PHQ-9 is a big confounder. At least some of our initial data looking at Timoth's work, it seems like there's an association, but I don't think we're not clear if this is if PHQ-9 is different between intervention groups. So you have other variables in your demographics that show to have a different pattern that might be interesting to add here as a sensitivity. I would start by analyzing without them and then adding them on to see how confounding adjusted what you're analyzing. I don't think it's going to change your analysis. I think in the end, when you're making conclusions out of this, you have to be very careful that this is a secondary analysis. You have a group that is very imbalanced from the other group, and maybe then that doesn't really illustrate the difference you were looking at. And it could be just by the fact that you don't have enough data here to show the difference, or maybe the difference is not there, but either way, you can't. Lack of evidence doesn't mean the evidence is not there. It just means that for this data doesn't support that hypothesis. But you can only make that assumption that the lack of evidence is evidence that that association is not true when you have proper powered data or powered sample. So that's something for you to be careful about.
Yeah, I had tried also, I had run the model without the adjusting for audit HQ9 and 6. So it wasn't significant, even though I didn't. I was just exploring like
I would assume so. I think that it's clear from the descriptive data that there's not a lot of variation between these two groups when you account for it. So I wouldn't expect it as well. But in the end, you have to report a model that makes more sense. Okay.
Yes.
All right. Does anybody have comments here?
Same comments here.
Rini, I can comment on the binary the dichotomization discussion on the age. When I was running a few tests, I ran into the same issue as you. So we have a small sample of patients if we create age classes or age groups. If you're doing complete case analysis, then you're doing moderation, you kind of reduce down the sample even further, and you end up with small numbers for each of the possible combinations. So baseline, young, and if you add other variables, like you're doing audit for adjustment, you're doing sex, you're doing PHQ-9. So the multiple combinations there kind of really reduce your sample size even further. So that's a problem. For one thing to try to control for that, and you said that you tested that as well, is to use the age as a continuous marker. But then, since you want to look at the effect of groups, you can use the coefficients for the unit the unit change for age and derive changes for 10 years, 5 years, and do the comparison afterwards.
Yeah.
That way you still can fit the model and maybe don't run into the same sample size problems, but then you could derive that from the model as well to get those conclusions that you are looking for.
Thank you, Jovita. I'll try that also.
And the other thing that came to mind, I think is it table 4? Can you switch to table 4, please? Yes. So you say mixed effect regression with random intercepts, and before you mentioned also that you're using a negative binomial. I just wanted to check if you use different models for each outcome based on the type. For instance,
Yeah.
for audit, is it linear? Just to check.
Yeah. So for audit, drink, and PHQ-9, it was linear. For drinking days and drinking amount, it was negative binomial.
Okay, cool. I see that below the table now. So thank you for clarifying that.
Winnie, I just want to comment on your conclusions. Really nice presentation. Thank you for putting this together. I think we have to walk through some of the conclusions and how you stratify them by age and young people. I don't fully understand them or where you got them from the data. So I would say once we get through finalizing the models, let's talk through these again and make sure that we can understand not only like the steps of like how lack of evidence got to this conclusion and then sort of next steps moving forward.
Okay. Yes,
Nicely done.
Thank you, Catherine. Yes, so I think, yeah, it was not clear because I didn't put like the table for the stratified analysis. So one thing I went ahead and I just looked at the effectiveness of intervention in each age group separately. So I looked at it for the young people on their own and the adults on their own. So that's when I thought of this conclusion, but I'll do the corrections and I'll work on it better.
Sounds good. Thank you.
Yeah, Winnie,
To that point, Winnie, can you go back to that figure that shows that? You said you didn't put the table, but I know you put the figure. To me, maybe it's just me, but I don't find this figure easy to interpret. I think it would make more sense and be more interpretable if the young and the old were stacked on top of each other for each outcome, because you can't tell where one ends and the other begins because they're together. Do you understand what I mean?
Yes, absolutely.
Yeah.
Thank you. I'll change that.
And then also back to the slide which Catherine was commenting on, I put in the chat, this is not a substantial comment, but it can be confusing when I'm reading your results. I would suggest changing these labels from adults and young people, because it mostly suggests that young people are not adults, which in your case they are. And to me, when I read your results, it becomes confusing. So for example, the last bullet on the left suggests structured BI may be less critical for adults. I find that confusing because I'm thinking of adults as all of these people. All of these people are adults by some definitions. So I would suggest changing the labels in your two groups if you keep a dichotomized model.
can you go back to the figure? Yeah, I agree with Ashley's comment. So these are the incidence risk ratios for each group. And this is just overall. It's not assuming baseline 3 months. It's not assuming intervention, non-intervention.
Yes, in this figure, yeah, it didn't. So that's why I said I think it wasn't very self-explanatory, because in the table I have for the intervention and I have for time and interaction within the age group. So it was more clear. So I think to revise that, I'll make the plots. I have plots which are showing the how it's changing within age groups. I had them in my manuscript. So I think, yeah, this figure, I agree, it's not clear.
Okay. All right. Yeah, let's try it again. And then it would be great if next time you present, you show your codes to see how you fit the models.
Okay.
But yeah, overall, I think the narrative is very good, and we have to adjust the analysis piece to just make sure it's robust. And I think the result you'll find is what you found. I think there's not a big moderation here. And part of it, I don't think it's in your discussion, you're gonna need to be very careful to discuss that maybe this is theoretically and this is an age difference, but maybe it's just a data problem, and there's something around the outcome as well, which is a complicated outcome. So showing some of the results on the other outcomes might make sense as well.
Okay.
All right. Well, thanks for presenting. I think this is exactly the spot for us to be able to give open and direct feedback, so you can go and present externally with more quality and more certainty. So that's good. Appreciate that, Winnie.
Thank you for your comments and to improve this work. Thank you so much.
Sure. All right, cool. What do we have next week?
We have Andresa from FMT for Qualitative Tuesday.
Cool. Sweet. All right. Thank you. Bye.
Thank you. Bye.
Thank you all. Bye-bye.